We are now on part 3 of chapter 8. In this section we will discuss virtualization, page 366. Virtualization is a big deal these days. There are two general categories of virtualization: operating system virtualization, which is also called server virtualization, and application virtualization. So let's look at each one of those. We will start out with operating system virtualization or server virtualization. So in this section we will discuss what is virtualization and why should we use it. But before we discuss virtualization, first let's review what's meant by non-virtualization, where you have traditional servers. In the traditional server-based network, you have multiple servers. The user stands at the workstation, connects to a switch, which connects to a switch in the server room. And in the server room, there might be multiple servers: file server, application server, domain controller. And each server is in a separate physical computer. Each server is in a separate physical box. This is the traditional server-based network that most of us are familiar with. The problem with server-based networks is that there is an inefficient utilization of resources. So here's an example of when we first started our server room a long time ago at CCBC. We got 4 separate servers, and each server had 4 CPUs and 8 gig of RAM, and at the time, that was a lot. And on the first server, we figured we would make the first server a DNS server, the next server would be a DHCP server, the next server would be a file server, and the last server would be a registration server. Notice they all have the same number of CPUs and RAM. But after we got all the software up and running, we found that the DNS server and the DHCP server were only using 25% of their resources, and that the file server, and most importantly the registration server, were totally maxed out. Now I wish I could just take my fingernails and pull out a couple of the CPUs from one of these servers and move it to one of these servers, but it's just not that easy to do. In the traditional method, you have a separate physical box for each function. And the disadvantage is an inefficient allocation of resources. Some servers are totally maxed out, and other servers are not even using a quarter of the allocated resources. So the solution is to implement server virtualization. Server virtualization is where we install multiple server operating systems on one big computer. At CCBC, we have this big old blade server, and it's as tall as I am. And it has multiple blades, and each blade, it looks like a lunch tray. But if you pull it out, you will see that this blade has 2 microprocessors and 4 gig of RAM. Each blade it's kind of like a motherboard, and you know what a motherboard is. It's a circuit board that has a microprocessor and RAM on it. Well, a blade is kind of like a motherboard in that it has 2 microprocessors and 4 gig of RAM. So if you put 32 blades in one blade server, that gives you a total of 64 processors. Now when we first bought our blade server, we only put 4 blades in it, but since then we have bought more and more blades, and now it's completely filled up. So to implement server virtualization, what we do is we install multiple server operating systems on one big computer. And each one of those server operating systems is called a virtual machine. The ESXi hypervisor, the hypervisor is the software that allows the blade server to host multiple operating systems. The hypervisor is really the operating system for the big blade server. And VMware makes a hypervisor which is called ESXi, and Microsoft makes a hypervisor which is called Hyper-V. So when we say that a computer is an ESXi host, we mean it's a big old computer, but it's running the VMware software on it. VMware calls their host ESXi. An ESXi host is a big old computer, it's a big old blade server, which has VMware ESXi hypervisor installed on it. Multiple virtual machines run on the ESXi host. So if we view the contents of the ESXi host, we will see that there are multiple virtual machines running on this one big computer. If I look at the screen of this big computer, I can see there are multiple server operating systems running on this EXI host, and each one is using a different amount of CPU utilization, and each one is using a different amount of RAM. Since different servers have different requirements, we allocate different amounts of RAM and a different number of CPUs to each virtual machine. What we do is we allocate, for example, 1 CPU and 2 gig of RAM to the DNS server, or 2 CPUs and 4 gig of RAM to the DNS server, or 6 CPUs to the file server, or 7 CPUs and 10 gig of RAM to the registration server. Can you do that? Absolutely. That's one of the big advantages of virtualization. Multiple operating systems running on one big computer, but different operating systems are using different number of CPUs and different amounts of RAM. So if we compare the traditional network infrastructure to the virtual network infrastructure, in the traditional method with separate servers, the disadvantage is inefficient allocation of resources. Some servers are only using 25% of the resources. Some servers are using are totally maxed out. But when we use virtualization, we have multiple virtual machines running on one big ESXi host, and different virtual machines are assigned a different amount of RAM and a different number of CPUs. That was server virtualization. Now let's discuss application virtualization. Application virtualization can be defined this way. A virtual application is an application that appears to be running on the local PC, but it is really running on a remote server. Now, typically an application runs on the CPU of the PC where the user is standing. That's a typical application. But with application virtualization is based upon the mainframe model of computing. And as you know, a mainframe is a big old computer which is in a separate air-conditioned room. And for users to access the mainframe, they stand at dumb terminals. A dumb terminal is just a keyboard and a monitor. Now you know what a PC is. A PC has a keyboard and a monitor and a CPU. But a dumb terminal attached to a mainframe has just a keyboard and a monitor. It doesn't do any processing. So typically the user stands at a dumb terminal and the dumb terminal connects to the mainframe. The mainframe has lots of CPUs and the dumb terminal has no CPUs at all. If a user types 2 plus 2, the 2 plus 2 is sent down the wire to the mainframe, and the CPUs on the mainframe add up the number 2 plus 2 to give us the number 4. No processing occurs where the client is on the client terminal. That's the mainframe model. In a mainframe model, the processing occurs on the big mainframe computer. Now, in a typical local area network, where when a user is working at his PC, if he adds 2 plus 2, all that processing occurs on the CPU of the individual PC. And the server might have 8 CPUs and none of them are being used. That's a typical LAN. Typically, all processing goes on in the processor of the PC, and users can save their files up to the hard disk on the server. However, in application virtualization, the 2 plus 2 occurs on the server, and thus instead of using 1 CPU, the user is using, in this example, 8 CPUs. Application virtualization is where the application appears to be running on the client's workstation, but it's really running on a remote server. And if the server has a large number of CPUs, then you can see that the user has access to much more processing power. Here's an example of a virtual application. It's a payroll application, and I am calculating somebody's paycheck for the week. And if you look at this, it looks like I am running it on my own computer. But if you look a little more closely, it shows that we are using a remote desktop. And with a remote desktop, you are actually running the application on a remote computer. So with application virtualization, the big advantage is that you only need to install an application once on the server. You don't need to go to every single workstation and install the application on every user's workstation. You just install it on the server because that's where it runs. And furthermore, the client computers don't require much processing power because all processing power occurs up on the server. Of course, the drawback is there is very, very heavy processing load on the server, and if you get too many people using it at the same time, then that can slow it down. So we have two types of virtualization: server virtualization and application virtualization. Now let's turn to page 380 and discuss operating system installation. To install an operating system, you walk up to the server with your install DVD, put the DVD in the server, and turn it on. When you turn it on, it should boot to the DVD. We turn the server on, it boots, and it says press any key to boot from the DVD. So we press any key, and it boots from the DVD. You can see Windows is starting, and then it takes us to the Windows setup program. To install Windows, I click on Next. It then asks me what edition I want to install, Standard Edition or Data Center Edition. In this case, I will install Data Center Edition, followed by Next. I accept the licensing agreement, and I click on Next. I click on Install Windows, and I select the disk that I'm going to install Windows on. In this case, it's pretty simple because there's only one disk to install it on. And I click on Next. And then the operating system files copy from the DVD to the hard disk, which is located on the server. And after all the files have copied, then the server reboots, and the server restarts, and it reboots. And this time I don't press any key to boot from the DVD. I don't press any key to boot from the DVD. Then I log in as the administrator, and then I go to the program called Server Manager, and under Local Server, this is where I configure the server. When you first install a server has a randomly generated name. So what we do is, the first thing we do is we click on the name of the server and click on Change, and we get rid of that randomly generated name, and then we type in a name for this server, what is called a host name. In this case, I will just call it Server 1. And then I will give it a DNS suffix of ccbcmd.edu. And then after I configure the server name, then I configure the IP address. I go to TCP/IP, and I right-click on my Ethernet card, followed by Properties, and then I go to TCP/IP and select Properties, and then I give the computer an IP address, and then I assign it a subnet mask, I assign it a default gateway, and then I type in the IP address of the DNS server, then I click on OK, and close, and close. And one more thing I need to configure is the time zone. I select the time zone, select Change Time Zone, select the drop down for -5 hours Eastern Time, US and Canada, followed by OK. And that's it. I'm installed. So when you install an operating system, you put the DVD in, you turn it on, you boot from the DVD, and it copies the files from the DVD to the file server hard disk. Then you log into the server and you assign it a host name. In my case, I just called it server 1, and a DNS suffix, such as ccbcmd.edu. We assign it an IP address, and we specify the time zone. Page 382 discusses selecting the right Windows edition. And we will see that there are 4 different editions of Windows 2012 Server. Now, Foundation and Essentials, that is those are economical operating systems for small businesses. Most of us will not be working, I mean very small business, like 5 employees. Most of us will not be working with Essentials and Foundation. Most of us will be working with Data Center and Standard Edition. Standard would be for a medium-sized organization, and Data Center would be used if you had a large organization. Data Center is typically installed when you have a large data center server with a large number of CPUs and a large amount of RAM, and you plan to install many virtual machines on that data center server. If we look at the prices, we can see that the low-end cost of Windows Server 2012 is $679. Conversely, that's just the Standard Edition. If you look at the Data Center Edition, that is $6,000, and that is the software alone. We've been talking mostly about Windows servers because Windows is the most popular operating system, but the UNIX/Linux operating system is also a well-known operating system. When they first started with the UNIX operating system, it was developed at University of California, Berkeley, and they called it Berkeley Unix. And it is considered to be a robust operating system, and robust means it doesn't crash 5 times a day. And furthermore, it is a command line operating system, and in a command line, you got to type all your commands in. To create a user, you type add user Bob. To create a group, you'll call add group sales. To add Bob to the sales group, you would type add Bob sales. In 1991, they came out with a version of Unix called Linux. And it's nearly identical to Unix in that it is a robust operating system, but the great part is it's free. It's a good operating system and it's free. And then Red Hat has their edition of Linux, and even IBM has their edition of Linux, and it's called AIX. Chapter 8, Summary. In this chapter we discussed what's an operating system, what is a network operating system. We looked at operating system components, the purpose of an operating system, sharing and mapping, account management, authentication, authorization, group policy objects, local storage, centralized storage, storage area network, and cloud storage. We saw that DNS performs host name resolution. We looked at fault tolerance, at virtualization, at operating system installation, and at operating system additions. And this concludes Chapter 8. Thank you very much.